Okay, so y'all asked for some extra practice. Oh, Siri, I'm not talking to you. Extra practice on balancing redox equations. So I have a few examples pulled up on my phone. And so this is my equation. I'm told that it's in an acidic media. And my question that I'm going to answer is, what is the coefficient in front of water? Okay, so this is kind of what it would be set up. So what I want you to do is go ahead and take a break. Well, not break, pause it. No breaks yet, we just started. Pause it, and then come back, and let's see if we can solve this together. So the first thing we're going to do, the first thing I want you to do is to break it into two half reactions. Okay, so pause here and do that. All right, so this should be what you have. Chromium, nitrous acid, or yes, nitrous acid and nitrite ion. Excuse me. Okay, so now we are going to mass balance the atoms we currently have, not anything else. So pause here and let's mass balance only the atoms, not adding any water or anything else. Okay, so the only thing I should have had to add was adjust the number of chromiums on the left-hand side, because I'm going to balance oxygens and hydrogens with water and protons. So I'm not going to balance those yet. Now, number 3 is now I'm going to add my waters to balance my oxygens. So now, pause it here and add those oxygens, or add the waters to balance the oxygens. Okay, so I should have added 7 waters on the left-hand side equation and then 1 water to the right-hand equation, but I'm adding it on the left side, which is confusing. Okay? All right, so number 4 is adding protons. Okay, so I'm going to add protons to balance out the protons I just added in the water. So pause here and go ahead and add those. Okay, so I should have had to add 14 protons to my left-hand equation and 3 protons to my right-hand equation. Now I have to look at the charges. So now I need to balance out, well, first I need to determine what my overall charges are on both sides and add electrons to make them equal. So in this case, I have 14 plus 2 minus, which must equal 6 plus, because it's 2 times 3 plus, then plus 0, because that's neutral. So I need 12 plus to equal 6 plus. And the only way to do that is by lowering the left-hand side. So 6 electrons and then nothing else changes. Okay, so let's do the pause here and do the same thing for the other side. Telling them to pause it. Just a minute. All right, so what you should see is you need to add 2 electrons to the right-hand side. of this equation to make it equal the 0 charge on the left-hand side. So add 2 electrons. Okay. So now the next thing is to make the number of electrons equal each other. I'm going to do that by multiplying the whole equations. So I have 6 electrons here, 2 here, so I need to multiply this entire equation by 3 so that I can cancel my electrons out. My lines are not matched up. It should drive me crazy. Remember, the 3 is going to multiply across the entire equation. Oh, 3 times 3 is 9. That's good math. Okay, so now my number of electrons are going to equal, or they do equal each other, so now I'm going to add the equations together, and with canceling out anything that they have in common. So 6 electrons, 6 electrons. I have 14 protons here and 9 here, so all of the 9 are going to cancel out, and I'm going to be left with 5 over here. I have 3 waters on the left and 7 over here, so I'm going to be left with 4 waters, and then nothing else should cancel out. So now I'm going to add them together. So added those, added that. I'm going to do my arrow, 2 chromium 3 plus 4 waters plus 3 NO3 minus. Okay? So everything should be balanced. So I have 5 protons plus 3 is balanced with my 8, 2 chromiums, 7 oxygens here, and 6 there, which gives me 13 oxygens. And over here I'm going to have 4 plus 9. Yeah, that's 13. 7 plus 6 and 4 plus 9. Both equal 13. Okay. And then nitrogens, I have 3 and 3. So everything's balanced out. Now overall charge, I have 5 plus, 2 minus, and 0, 6 plus, 0, and 3 minus. So 5 plus 2 minus is 3 plus, and 6 minus 3 is 3 plus. So my mass balances out and my charge balances out. So this is my final equation. And the question says, what's the coefficient in front of water? Well, that's 4. Okay, so that should be an acidic example, and this should match kind of like the same wording you heard on the quiz. So come back and we'll do a basic example.